1974 XB,
Yep.
Falcon 500.
Seven years ago, we published a simple video about building a high horsepower street-based Ford V8 engine. Today, this video has millions of views on YouTube and thousands of comments. While overall it received a strong response, many of these comments simply sum up how pessimistic the internet has become. Putting the uninformed aside, we have consistently been asked by you guys for a more in-depth look inside what really goes on into building a high-output street V8 engine. So when Frank Marchese of Dandy Engines informed us of a project they had become involved in, we were more than happy to jump on board. Dandy Engines has been in operation since the mid-90s and features complete in-house machining services and dyno tuning facilities, servicing customers from restoration work to supplying race teams. Dandy Engines also holds numerous Australian drag racing records, as well as winning Street Machine's prestigious Drag Challenge event on their first attempt. To say they have the runs on the board is an understatement. Dandy Engines has built a stable of naturally aspirated high-output, big cube, small block V8 street engines, so this one isn't that much different. For this particular engine and the owner Klim, the goal was quite clear: make as much power as possible on pump fuel, whilst maintaining good street manners and to fit under the factory bonnet of this Ford XB coupe. Let's take a look at an inside view, starting with an iron block by Dart. Over to Bob, who is taking a close-up, preliminary look.
I've measured the crankshaft journal with a micrometer, and then I've set this to the micrometer, so I know exactly what this is set at the shaft size. So when I put it in there, it's giving me the exact clearance between the shaft and the bearing. There is 1, 2, 3, nearly 3.5 thou vertical clearance, oil clearance between the crankshaft and the bearing, and they're all pretty much the same within a couple of tenths. And because the bearings are machined eccentric, you always get an extra thou across that way and that way.
Okay. Moving across to the boring machine, where Michael has picked up a set of ceramic-coated diamond-forged pistons. These are essentially bigger than the bore of the block. They are measured so Michael knows what the current clearance is of the piston to bore. Back over to Bob, who has moved on to checking the alignment of the Callies steel crankshaft. This is a critical step in order to minimise premature bearing wear. Michael is now setting up to hone the block. This process helps lubricate the piston rings as they travel up and down the cylinder bores. This is achieved by creating very fine imperfections on the surface of the bore itself. Dandy Engines bossman Lou is now performing lifter boring. This is a multi-step process as the engine is being fitted with solid roller lifters for less friction. In order to achieve a perfectly straight tunnel, the block is also line bored, on top of being prepared for a Torrington thrust crankshaft bearing. While Lou continues to work on the block, Peter is weighing and balancing the pistons and rods. Why would you do this, you may ask? Well, the rotating weight of these items will essentially affect the harmonics of the engine. A small imbalance could become quite problematic in an engine like this that will rev beyond 8,000 RPM. Peter sets up the bob weight, which basically represents the conrod, piston, rings and wrist pin. For balancing purposes, the crankshaft is spun up to 500 RPM, which is the recommended speed of the crankshaft for balancing, with the bob weight attached in order to determine where the imbalance might lie. Turning his attention back to the block, Peter is now honing the cam tunnels due to the larger, oversized camshaft core. Moving back to the top of the engine, Michael is checking that the valves are seating correctly.
We're building a 468 Windsor-based with a Cleveland head engine for a street car that wants a lot of power. We are enlarging the ring end gap to suit the application of the engine. It's a high compression unleaded engine, so therefore the cylinder pressures and temperatures will be high. Yeah, I like to just make sure the oil ring gap is sufficient. We are removing the sharp edges from the grinder, enlarging the ring gap. And we're using a diamond file, not just a normal file.
And now we need maximum lube, Frank, on this cam.
This will have plenty of lubricant.
Dripping in lube. Because last time we made the video, you didn't put any lube or oil.
I got caned for not putting enough lube, so there you go, guys. Everything's lubricated. We won't skimp on lube this time. Not that we had a problem with the last one, but for the viewers that thought we didn't put enough lube on it, we've got enough now. Okay, we've numbered these bearings as they've all been pre-measured and the crankshafts had the clearance ground into it. So we did check all our clearances first for those viewers that will question that. I like to lubricate the seal so it doesn't go on dry. This is a Kelly's Magnum. These are the caps that hold the crankshaft down, known as the main bearing caps.
So you torque these bolts down in two stages? 2
or 3 stages, yeah. These ones we're going to torque the first lot at 60 and the next lot at 100 foot-pounds. Now I'm using foot-pounds because I'm old school. I'm not using Newton meters. We're checking the end float on the crankshaft, allowing the crankshaft to just have a little bit of movement without binding. So we'll push it one way and find the end of the float and then push it the opposite way. And it has 6/1000 of an inch. Perfect. Okay, here we're checking the cam float. It's the end float in the camshaft, so the camshaft doesn't bind up. For instance, if that's too tight and it pushes on the camshaft, it can't turn. So we're just making sure that there's enough clearance on the thrust bearing so it doesn't bind up. 12 thou, I'm happy with that.
So you've already dummy assembled this engine.
Correct.
What is the purpose of doing that?
Just to make sure that all the clearances between the piston and the valve is correct, making sure that the crankshaft rotation has clearance. Nothing comes out of the box perfect. The end float that we were checking is for the crankshaft to have something to stop against without trying to grind into metal.
So like the last engine we filmed, this one's running a belt drive instead of a timing chain?
Correct. We just find it easier to manoeuvre on the dyno for changing cam timing and finding the sweet spot. This one has an external distributor, so it allows us to do more things. Just installing a cam seal plate. If you don't remove that key, it damages the seal. The fact that the engine's internally balanced, it makes it nicer when you've got a good dampener on there that doesn't cause any vibrations or harmonics through the engine. It makes the parts last longer. Just a retainer plate to hold the gear on. We may have to remove it if I'm a tooth out. Torqued up to a very small specification, very light. What we're going to do now is put the pistons on the rods, lube up all the bolts, and put the bearings in the con rods. And compression, static compression is one thing. It's dynamic compression is what it's about. So it's when you shut the valve and the piston's got to travel, if it's 90% of the ball or the last 30% of the ball, that's what's going to create your dynamic. And the dynamic is what can make a car ping. If you've got too much dynamic, like a lot of compression with a small cam is a big no-no, because you create a lot of cylinder pressure. But the bigger the cam, and then you add the compression statically, that allows the dynamic to be correct for the camshaft. We generally like to use an Oliver rod in an engine like this. That's going to make 800 horsepower plus. The Oliver rods have proven themselves to be strong and last a distance. The piston is a diamond custom piston. We like the coatings on them, just makes them last longer. The tops are heat coating, the sides are moly. It just helps the skirts be protected over time. It does rub off, so don't think it stays like that the whole time, but it takes a fair while for it to rub off. And the gold, well, it discolorates pretty much instantly, but the protection of the ceramic coating allows it to withstand. It won't stop it from melting a piston, but it will withstand heat, excessive heat, if you do miss the tune up a bit. An Oliver rod is a highly priced rod, but they do have a good reputation. We run them in turbo cars that make 2,000 plus, so you know they're going to survive all day long in a 800 to 900 horsepower engine. In this combination with this camshaft, we like to run around 12.5 to 1. We know it works well with 98. We've had cars run 970s in a 3,500 pound car over the quarter mile, so we deem it to be good enough there. We've tried 13 to 1, but it just doesn't work as good as 12.5.
Do the pins come with the pistons, or are they an extra?
You've basically got to order what you want. The thickness of the pin, the size of the length of the pin. So they are an extra when ordering custom pistons. Okay, these are the spiral locks that hold the gudgeon pin or the wrist pin in place. Australians say gudgeon pin, but I know the Americans will be like, what's that? It's a wrist pin. There's 2 per side, so each piston has 4 of them. Not many people like fitting these, but over the years I've learned to just deal with it. Because the camera's on me. They're called gas ports, and the purpose of them is to trap, well, the compression goes into the hole and presses against the ring, harder against the ball, so it gets better sealing. You can just see them in the top there, of the top ring. We're putting the oil ring spacers. They hold the actual, there's 3 bits to an oil ring, and you can, if you include the rail at the bottom, there's 4 pieces. Then we fit in the second ring. Plenty of lubricant. We're making sure the taper ends up on that taper. Because if we were to put it that way, the square edge would bind up in that corner radius.
So what are you doing there?
Just checking the end float, making sure the rods have got enough clearance. If they were tight, that means they were going to bind up.
So Frank, you're just dialing in the camshaft by the looks of it?
Yeah, correct. We are making sure that the valve vents in the cylinder head occur at the right time in relation to the piston. And by changing that valve event, it can alter the power band of the engine.
Like many high-powered small block Fords that Dandy engines build, this engine will be using cylinder heads by Higgins Raceheads. These are Australian manufactured CNC ported, flowing over 400 CFM and come in street and race variants.
We are setting the spring install height, which is when the spring sits with the valve shut. It would pretty much give us a pressure.
So this is the installation of the valve stem seals?
Correct. It just stops the oil from going into the cylinders.
What valves are these?
Faria 6000 series. All right, here we go.
So what's that telling us, Frank?
Okay, the spring rate of the spring, basically, and then the installed height is where the spring is mounted in the cylinder head with the valve shut, has 257 pounds of seat pressure, and then when the valve is fully open, it will show here around 840.
So you use these sealing rings in quite a few high horsepower engines now?
Yep, we find that they seal 100%. Mainly in our boosted application, we find that they're almost more worthy to run, but if we can trap everything in an aspirated engine, we'll make more power. I did last time, it worked. They're probably going to tell me that I'm pulling on the torque wrench too hard. Using this type of head gasket is our choice. It doesn't mean that you can't get away with the other one. It's just something we prefer. Machining these blocks down to clear the studs, just making things fit in the motor. Not everything comes out of the pack at 100%.
What do you dunk them in oil for?
I like them to soak and fill the rollers up with oil. Yeah, this is extreme
lube.
An extreme lube for high pressure use. Taper clearance is important, unless you've got an LS with a hydraulic cam. Just going to take some of the clearance up so the push rod doesn't pop out. We're setting the lash so that we'll set the clearance between the valve and the rocker tip. In this case, it's 18 thou, which is...
It's 30 thou 1 mil?
40 thou is.
40 thou is.
So it's about...
Okay, so it's about half a mil.
Yeah, half a mil.
What sort of oil capacity does this sump hold?
These hold generally about 6 litres, 6 to 6.5 litres. We put 7.5, so by the time the engine starts, it fills the oil filter and probably all the oil galleries.
With the engine complete, it's ready for the dyno as Frank finishes off the final touches.
The reason for not putting the water pump on the dyno is so we can get to the cam gear and adjust the cam timing. The crank trigger tells the ECU when the crankshaft, or which position the crankshaft is in, so we can determine when to fire the injectors and the spark, which is that unit there.
Frank, we've finally got the engine on the dyno. It's been a long time coming, a lot of work.
Yeah, doesn't happen overnight. The engine's been running, which it's a roller cam, so pretty much all we do is bed the rings in. We've made a few pulls, established what we want to establish on the fuel map and ignition map, and then we've removed the intake manifold and lowered it down, so we're hoping to make all this fit under a bonnet of an XB coupe. So we've dropped the manifold as far as we can.
Yeah, because it wasn't going to clear, was it?
No.
He didn't want to run a...
it was too high before
a cow scoop.
Yeah, it was too high for what we were doing, so we wanted to look as a sleeper as much as we can.
Yeah. Alright, why don't we start it up and we'll get back into tuning.
So there you go, guys. We've finished up with an 866 horsepower, 640 foot-pound. We're pretty happy considering the manifold's been chopped down to fit under a bonnet of an XB. Time will tell when we go for a spin in the car how good it is. Okay. This has been built to suit the application of what we're doing, which is building a street car with as much power on pump fuel, keeping it all restricted to under the bonnet, and we've installed an FT500 fuel tech. Something we like because it's basic. Comes with a pre-made harness, plug and play, and we can ride a map consisting of pounds per hour. So same as a carburetor, which made it very quick to ride the fuel map.
One point I wanted to touch on, a lot of our videos, people, I see they say the engine's laggy and they don't understand the dyno is controlling the engine. They just see the throttle cable and say it's laggy. Can you maybe, in simple terms, explain why that is?
It's very simple. As we open the throttle on the controller here to wide open throttle, the butterflies go to 100%. I set my low RPM, which is no different to setting your store speed on a converter. And then we release the button, no different to releasing a trans brake. And therefore it will climb at 300 RPM per second, allowing the engine to reach its maximum RPM of 7,700. So it's no different to releasing the trans brake and then duplicating or simulating what a car does in top gear.
Yeah. So it's simulating what it's doing in the back end of the track.
Correct. It's no different. It's almost like seeing the gear change on first to second, and then you're recording the data from when the engine drops to its lowest RPM point, which is what the store speed controls, to its highest RPM point.
So at the moment we're still working our way through putting the motor in the car and setting up all the fine details, where we're just mocking up how we're going to get up our steering system to sort of work with the mechanical oil pump with the fuel pump cable running off the back behind it. Got the alternator on the left hand side mounted low because we're trying to keep everything neat so that we have, you know, the majority of the cylinder heads exposed and we can sort of see the beauty of the motor. Still got a fair bit to go. Just mocking up the fuel tech loom at the moment, making sure we've got a place to put all of the sensors, and then whereabouts we'll put you know, things like the fuel lines coming up into the back of the motor, making sure we have clearance from the exhaust everywhere we need to. So it's a cable driven mechanical fuel pump, a Waterman one. So we run it's like a thick speedo cable that runs down off the back of the mechanical oil pump. So we run that underneath the car, clear of everything, into the fuel pump, and it drives it mechanically. We find that's a lot more reliable and gives us more consistent fuel pressures. And then we have a small little primer pump, which just will come on for a couple seconds on startup, just to make sure that the mechanical pump's primed and that it's going to fire straight away, and he's just going to be able to lean in, hit the key, and it starts every time. We still got a hole that we've got to patch up in the boot floor that was there when we got the car. So we'll go through, once everything's sort of mocked up and we know where all the lines are going to be, we'll just be able to tidy everything up and get the finished result we want. So wheelwoods front and back with, I think they're all 4-pot 355mm rotors on the front and rears, with a set of extractors we got from Competition Engines. They supplied them for us. And then we got the Marchese sump, and then we do a mechanical oil pump, which is our normal deal on a motor like this. These are just mocking up lines at the moment, so we'll remake them once we sort of know everything's going to fit and exactly what angle fittings we need everywhere. We've got a 2-speed power glide behind it with a TCE converter, twin 3.5-inch exhaust, which we've just tacked together at the moment. So we'll buff and clean it all and then TIG weld the whole system before we finish it off. So we're running, on this particular one, we're going 3.5-inch over the 9-inch diff, so it's a pretty tight squeeze, but you know, we're working through that and making sure we have clearance so that it's not going to interfere anywhere. We've got 4 Hooker aero chamber mufflers, which for a car making this much power, it's going to be fairly loud, and we find these, you know, give it a good note and keep it pretty quiet. Yeah, this is what we normally run, the weld-on fuel pressure reg. Because he's got a bit going on in his engine bay, we'll probably put this in the return line in the boot and look nice there, and we'll move the sensor up into the fuel rail or something like that. Got a Systems 1 remote oil filter, which will tuck up under the passenger guard and run, you know, through bulkheads, through the inner guard into a nice little serviceable item there. Try not to have anything underneath it, so that when you open it you don't spill oil over everything underneath, and you can check it regularly, because it's a really good way to figure out if something's hurting the motor or not. So we've basically just been setting up the loom inside the car a little bit. We started off with a Fuel Tech terminated loom, so it's pretty easy. It already has all the plugs on it. So in consultation with Klim, we sort of figured out he'd want to keep all of his own factory dash cluster, and to not ruin that, we're able to bring the Fuel Tech harness through the dash and just have a simple mount here, and we'll mount it, you know, put the block off plate behind it and make a nice little mount for it. So on that he'll have all of his fuel pressure, you know, oil pressure, water temp, stuff like that. RPM will all be displayed. He can make on-the-go changes to the tune-up or anything like that if he has various different tunes for different things like that. And that's the whole ECU, so that'll control the entire engine system. And it's a nice clean look, just being able to mount one little simple thing and keep the, you know, classic original interior intact.
I've just spoken to Frank at Dandy Engines, and he tells me that XB is up and running, so we're just going to head down there now and check that out. Got it up and running, Frank?
Yes, it's finally all come together.
I'm going to pop the bonnet and give us a look. Awesome.
Just got the overflows for the, well, not the overflows, the breather tanks coming. Last 2 things to plumb up and good to go.
So 2 years in the making, you must be pretty hanging
Yeah.
to give this a bit of a spin.
I can't wait, mate. I'm excited.
Let's go inside and have a look at it.
Let's go.
So Clem, tell us a bit about the car. What year is it?
It's 1974 XB.
Yep.
Falcon 500 GS. Original black car with the W2 trim.
And you've had it, you said it earlier, about seven
about
years?
7 years now, yeah.
And you had a sort of a bit of a mild engine in it before this?
Yeah, just a mild, well actually I worked 351 and it was time for an upgrade.
Yep.
You know, I have the feel I need the power there.
Yeah, it's a fair upgrade.
Yeah. Oh,
So-
why not go all the way, eh?
Yeah. So the wheels were on it?
Yeah, the wheels were on it when I
Yeah.
bought the car. I actually bought it off a friend. So I've upgraded, you know, running gear and brakes and all the suspensions new and all the interiors redone
Yep,
to the
yep.
factory specs.
So she's got the injection on this one too, hasn't
Yeah,
it?
injection, yeah.
Fuel Tech. It's got Higgins' new forward heads on it. I like the fact you've got it all under the bonnet.
Yeah, that's what I love, mate.
Yep.
I don't like you know, why ruin
know.
an expensive bonnet you can't replace.
Yeah, exactly.
that often.
All right, what do you say we go take it for a drive?
Yeah, let's go.
None of this Audi 5 countries. How's the first drive?
Beautiful, mate. Loving it.
Looks pretty smooth.
Yeah,
Like,
drives
Super,
beautiful.
super smooth.
Doing about 100 k's at about 3,100 up here.
Yeah.
It's a shame when you get to the destination because you just want to keep driving.
Better than I expected, mate.
Yeah.
Awesome.
It was pleasant. It was just too pleasant.